Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about direct algebraic proof. So, what we've talked about previously, the sum of two odd numbers is even. Imagine that's a conjecture. Look, let's be honest, we all know it's an actual true statement, and I've got to prove to you it's true. But when that first arose, that was a conjecture. Someone didn't know whether for sure it was true and false. And in the last skill we talked about a conjecture and counterexamples. So what someone would do is they'd try and add together two odd numbers and they'd see if they always got an even number. So they would say things like, I don't know, 3 add 5 is 8. Okay, that's even. It seems like this might be true. They might say 7 add 11 is 18. Okay, that's even. Maybe this is true. And for a start, you try and add some odd numbers together and see if you could find a counterexample. All it takes is finding one counterexample to prove that your conjecture is false. So you'd have given that a go. Having given that a go for a while and not been able to find a counterexample, you might think to yourself, right, it's time now to try and prove this. And that is what this video is about. We're going to use algebra to prove these statements absolutely logically and rigorously using algebra. Now, before we launch in and actually prove that statement, there's a few little algebraic tips and tricks that can help us with these type of proofs, and they're as follows. These are really helpful skills. If you're trying to prove something about any number, you can use a letter to represent it. So you could use anything you want, but usually in these type of proofs we use n to represent a number. Now, what about if it was an even number? Well, remember, all even numbers are in the 2 times tables. So what we would do is we would usually represent it by 2n. Or if we wanted a different even number, we might call it 2m, for example. But it's 2 times n, or m, where n and m would be positive whole numbers. Okay? What about an odd number? Well, an odd number is always an even add 1. We usually do that for an odd number. Or if it was a different odd number, we might call it 2m add 1. Again, n and m must be positive whole numbers. What about consecutive numbers? Well, if we wanted two consecutive numbers, we usually call them n, and we'd call the one after it, remember consecutive means directly after it, n add 1. And what if someone said 3 consecutive numbers? Well, a little trick here for that. We might say n, and the one after it is n add 1, and the one before it is n subtract 1, and they're 3 consecutives. We usually use that little trick to help us with those proofs. What about if someone said consecutive evens? Well, an even is 2n, and the even after it, well, it's not the number after it now, it's the even after it. It will be 2 more than it. It would be 2n add 2. And what about consecutive odd numbers? Well, if one of your odd numbers was 2n add 1, then the one after it would be 2 more than it. Okay, it's like, for example, 5 is an odd number. The next odd number is 5 add 2, which is 7. So this one might be 2n add 3. And they're going to be super useful for us to do these proofs, and that is the main idea you need. You need this little bit of algebra to get us going with these proofs. Let's do a proof, yeah? The sum of two even numbers is even. Let's try and prove it. So let's let one of the even numbers, so why don't we say n and m be positive whole numbers. Then certainly we know that 2n and 2m are even. That's definitely true because I've multiplied those numbers by 2. Now let's add these two. 2n add 2m. Well, what we could do is we could factorize the 2 out of that. That's like 2n add m. And look, this is of the form n add m. If n was a positive whole number and m was a positive whole number, if you add them together, they're definitely a positive whole number, right? So this is of the form 2 multiplied by a number. And you could just say it's of the form 2 multiplied by a number, where the number is a positive whole number. So therefore, when I added this and this, I got something of the form 2 times a positive whole number. So therefore this whole thing must be in the 2 times table. This thing must be even. Therefore the sum of 2 evens is even. Because when I add 2 evens together, I get something that looks like 2 multiplied by a positive whole number. That therefore is even, so the sum must have been even. And there you go, we have proved it. Let's try another one. This time our conjecture is that the sum of 2 odd numbers is even. So let's let again n and m be positive whole numbers. We know for absolutely sure that 2n add 1 is therefore an odd number. And we know that 2m add 1 is an odd number. And let's add them together. So 2n add 1 add 2m add 1. That's an odd number, a general odd number added to another general odd number. Now what can we do here? Well, 2n and 2m, we just have to write them separately. That's 2n add 2m. But we can collect like terms here. We've got positive 1 add another positive 1, which is positive 2. And we can take a factor of that 2 out. There's a 2 there, a 2 there, and 2 there. So we can factorize that as follows. And look, that's in the form 2 multiplied by a positive whole number. N add m add 1. That's certainly a positive whole number. So this is of the form of an even number. 2 multiplied by something. So therefore we can state that the sum, that 3 dots means therefore the sum of 2 odds is even. Because it's of the form 2 times our positive whole number, and we're done. Let's try another one. Pause the video and have a go. Now this time it says the product of 2 even numbers is even. Well, let's let n and m be positive wholes again. We know for sure that 2n is therefore an even number, and we know that 2m is an even number. And we're doing the product, so we're asked to multiply these and check if it's even. If we multiply these, we get 4nm. Now we can factorize out a 2. We can take a factor of 2 out, and that would be 2nm, like that. Now if n is a positive whole number, then and m is, n times m is a positive whole number. And then if you double it, that's certainly a positive whole number. So this thing is of the form 2 times a positive whole number, i.e. it's in the 2 times tables, it's even. Therefore we can say the product of 2 evens is even. Because it's of the form 2 times a positive whole number, and we're done. Let's have a go at another one. The product of 2 odd numbers is odd. Again, do the same old trick. Let n and m be positive wholes. Now we want to multiply 2 odd numbers, so we know that 2n add 1 is certainly of the form of an odd number, and we know 2m add 1 is of the form of an odd number, and we want to multiply them, so we're going to multiply these. Now we have to expand out the brackets. Let's do that. So we're going to get 2n times 2m, which 2 times 2 is 4, n times m is nm. 2n times 1 is plus 2n, and then we're going to multiply by 1, so we're going to add 2m add 1. Okay? Now, for this to be an odd number, we want it of the form 2 times some positive whole number add 1. So what we can do is we can take a factor of 2 out of here, because we've got the plus 1. Look, we've got the plus 1 we want, so take a factor of 2 out, and you get 2nm plus n plus m plus 1. Now this thing here is certainly a positive whole number because n and m are. So if you add n and m and you add it to 2 times n and m, that's certainly a positive whole number. So this is of the form of an odd number, and therefore the product of 2 odds is odd. Let's have a go at another one. The sum of 3 consecutive integers is a multiple of 3. We're going to add 3 consecutive. So there's one number, n. Let's do the one after it is n add 1. and let's do the one before it is n take away 1. And we're asked to add these numbers up. So let's do that. We can collect like terms, can't we? There's an n there, an n there, and an n there. So we've got ourselves 3n. And we've got ourselves negative 1, add a 1 is nothing. And that's of the form 3n, so it's in the 3 times table. So we can say therefore in 3 times tables, therefore the sum of 3 consecutive integers is a multiple of 3. And we're done. And that's it for this particular video. Thanks for watching.